brain's pattern-seeking machine. Your brain is built for one purpose above many others: finding patterns in the chaos around you. Every moment, countless signals flow toward your senses: sounds, sights, textures, shifts in light and movement. If your mind admitted all of it into conscious thought, the effect would be impossible to manage. What makes ordinary life workable is that your nervous system runs a constant selection process, deciding which fragments of incoming data are admitted into awareness and which pass by unnoticed. At the center of this system is the Reticular Activating System, or RAS. Located in the brainstem, the RAS is a network of nuclei that regulates arousal, attention, and prioritization of sensory input. Its role is well documented. It acts as a functional gatekeeper between the overwhelming outside world and the narrow spotlight of perception. When people describe the RAS as a spotlight operator in a theater, the metaphor holds real weight. Imagine a crowded stage, full of props and performers. Everything is technically visible, but you cannot focus until the operator swings the beam across the scene. The RAS plays this part in your daily life, deciding what deserves illumination and what slips back into the dark. Neuroscience has shown that this modulation relies on neurotransmitters like norepinephrine, serotonin, histamine, and acetylcholine, which alter the sensitivity of this system depending on context and need. In effect, these neurochemical adjustments determine which stimuli will stand out to you, whether it is the sound of your name at a noisy party or the cry of your baby in the middle of the night. The selectivity of the RAS means that relevance is not simply found, it is internally defined. If you recently searched for a job, chance encounters with help-wanted signs suddenly leap into view. If you are expecting a child, conversations about strollers seem to echo around you. Nothing in the environment has inherently intensified. Instead, the spotlight has shifted, giving priority to signals that match your personal goals or emotional focus. This process is automatic, but what it filters often feels quite intentional. A common example helps reveal this mechanism. Consider the moment after purchasing a new car, perhaps a bright red model. Almost immediately, you begin spotting identical vehicles on the road as if the world had suddenly filled with them. Statistically, nothing has changed. What has shifted is how your brain processes the presence of those cars. Since the new purchase makes them relevant, the RAS amplifies them in your perceptual field. In psychology, this is sometimes labeled the Baader-Meinhof phenomenon, or frequency illusion. While some interpret it as uncanny or even synchronistic, the underlying process is your attentional system teaching you what to see. Linking this back to synchronicity is straightforward. If the RAS selects which elements of reality enter conscious awareness, then meaningful coincidences, at least in part, may originate from this filtering. Someone anxious over finances might notice repeated references to money, articles, overheard conversations, sudden reminders of expenses. Another person preoccupied with relationships will more readily notice timing delays, unexpected encounters, or symbolic gestures tied to intimacy. From this perspective, synchronicities are not necessarily objective shifts in the external world. Instead, they reflect how attention moves toward information already present, producing the feeling that out there is aligning with in here. Importantly, the RAS is not simply an abstract psychological theory. Anatomically, it includes structures such as the locus coeruleus, raphe nuclei, tuberomammillary nucleus, and pedunculopontine tegmentum. Together, these regulate alertness and determine how stimuli are prioritized or ignored. This is why a parent can sleep through thunder, but wake instantly to the specific cry of their infant. The filter recognizes relevance long before conscious thought intervenes. By identifying and tagging cues linked to survival, goals, or emotional investment, the RAS turns raw sensory input into organized perception. The effect of this mechanism can be double-edged. On one side, it can serve human goals with remarkable efficiency. If you commit yourself to marathon training, your awareness tilts toward health-related cues: running shoes in shop windows, articles about hydration, new possible training routes. Each coincidence feels encouraging, as though surrounding reality were cooperating with your ambition. On the other side, the same system can trap individuals in cycles of fear or paranoia. If fear is the defining state, the RAS highlights potential threats, linking events that are otherwise separate. For someone in such a mindset, minor coincidences transform into seemingly hostile signs of persecution. The structure is the same, but the emotional content drastically alters the experience. Another reason coincidences feel striking is that the RAS links selectivity with emotional intensity. When the system flags information, it often does so because of personal value, not just novelty. That means attention is almost always entangled with effect. Strong emotion reinforces perception, and in this way a trivial overlap can escalate into something memorable. Perhaps you doubt a purchase decision, and then, by chance, see someone wearing the same item. That alignment feels reassuring, evidence provided by the world itself. Had you felt indifferent, the sight may have passed unregistered. The brain, through its filtering, introduces significance where raw probability alone does not. Still, while the RAS provides a convincing mechanism for how coincidences rise into awareness, it does not dictate how meaning attaches to them. That distinction matters. Neuroscience can describe how selective attention operates, but it does not by itself determine why one person treats a coincidence as profound while another dismisses it as trivial. The filter explains the noticing, not the interpretation. This boundary leaves room for debate. Some argue that synchronicity is simply perceptual bias layered upon chance, while others maintain that consciousness brings forward patterns just when they become most relevant. In either view, the RAS creates the conditions by which coincidences can accumulate personal weight. What is unambiguous is that the human brain is tuned toward order. From random noise, it extracts usable signs, draws lines between events, and constructs narratives that make the vast sequence of impressions manageable. To an individual, this process often resembles correspondence between thought and reality. To a researcher, it looks like cognitive economy, an architecture shaped to cut a livable path through chaos. Both interpretations fit, and both highlight the same fact. The noticing of coincidence is inseparable from the machinery that manages attention. Yet this same machinery sets the stage for a deeper problem. If coincidences emerge partly from how awareness is filtered, then how do we separate valid recognition of meaningful alignment from false patterns invented by the mind? The RAS explains why certain things appear to stand out, but it does not tell us whether those things truly align or whether our perception simply insists they do. The tension between actual connection and imagined structure becomes the next challenge. And it is here we must confront the possibility that what feels like cosmic design may instead be the brain's own tendency to impose meaning on chance. Apophenia and confirmation bias. Are coincidences showing us hidden alignments, or are they simply byproducts of how the brain processes chance? This question brings us directly to two key psychological tendencies, apophenia and confirmation bias. Both offer well-studied explanations for why people so often perceive synchronicities, and both highlight how deeply our perception can shape what we call reality. Apophenia refers to the tendency to perceive meaningful connections among unrelated or random phenomena. It includes experiences like pareidolia, where we see faces in clouds or human features in inanimate objects, and the clustering illusion, where random distributions appear to form patterns. Evolutionary psychology suggests this bias once served a survival function. For early humans, mistaking wind in the grass as a predator was safer than failing to notice an actual danger. Natural selection favored pattern detection, even if it created false positives. The legacy is a brain that constantly seeks order, often preferring illusory meaning over no meaning at all. This process extends far beyond visual illusions. In daily life, apophenia shows up as clusters of coincidences that seem too pointed to ignore. Suppose you run into several people from the same hometown in a short span of time. Statistically, this clustering may not be unusual, but your mind highlights the repetition and imbues it with symbolic weight, perhaps convincing you that the universe is nudging you toward that place. What stands out is not the objective rarity of the event, but the sense of personal resonance that comes from it. The feeling is genuine, even if the cause is cognitive bias. Alongside this, confirmation bias powerfully shapes how synchronicities are stored and recalled. Confirmation bias is the tendency to notice and remember evidence that supports pre-existing beliefs while disregarding what contradicts them. If you believe that a certain number follows you, you will register it on clocks, receipts, or license plates, while the countless moments when other numbers appear fade from memory. Over time, selective attention builds a convincing narrative that the number is chasing you. The same process operates if you believe you are unlucky. You will notice delays, mishaps, and frustrations, reinforcing the sense of a pattern, while overlooking the moments when things went smoothly. The two biases often reinforce each other. Apophenia generates the initial perception of a connection. a repeating number, a stranger who says exactly what you were just thinking, and confirmation bias strengthens that perception by focusing memory and interpretation in ways that fortify the apparent pattern. The result is a feedback loop where belief sharpens perception, and perception reinforces belief. It can feel as if the external world is responding directly to your inner state, when in fact your cognitive filters are curating the inputs you notice and preserve. One vivid example comes from gambling research. Slot machines, in particular, exploit apophenia and confirmation bias through near-miss designs. Three similar symbols appear almost aligned, giving the impression of being close to victory. Statistically, players were never closer to winning than at any other spin, but the near pattern tricks the brain's pattern recognition system. Confirmation bias then heightens the effect by making wins and near wins highly memorable, while letting countless losses vanish into the background. Behavioral studies back this up. Near misses activate reward circuits, even though no actual win has occurred. The mechanism is powerful enough that it sustains behavior long after rational evaluation would insist it is pointless. But these biases are not confined to casinos. Consider someone who sees repeated animal encounters as meaningful messages. A crow lands on their porch day after day, and soon the bird takes on symbolic significance, a sign, a warning, or an affirmation. Objectively, if crows are common in the area, their presence is expected. Yet apophenia elevates the coincidence, while confirmation bias ensures that every additional crow sighting becomes validation of the message. Patterns confirm themselves, and ordinary events transform into signs tailored to the observer's life. The interplay of these mechanisms helps explain why so many synchronicity accounts remain convincing even in the face of skeptical explanations. The perception of personal meaning is what gives these events their impact. Even if apophenia generates the connection and confirmation bias preserves it, the emotional experience of the universe speaking remains real for the person who lives through it. This does not mean the perception reflects external order, but it does mean the consequences can be substantial, guiding choices, lifting moods, or reinforcing personal narratives. It is worth noting that these traits are not always negative. Research has found that people more prone to noticing synchronicities often score high on measures of creativity and imagination. This tendency to detect unexpected links mirrors what fuels inventive thinking, the ability to connect disparate ideas into a novel whole. At the same time, studies also link synchronicity proneness with certain vulnerabilities, including mood disturbances and depressive symptoms. Psychologists describe this as a double-edged trait. The mind that connects random dots into inspiring insights can, under strain, also connect them into troubling or distorted narratives. The same sensitivity that fuels creativity may enhance well-being in one moment while heightening risk in another. Because of this duality, synchronicity experiences sit in an ambiguous space between adaptive and maladaptive cognition. On one hand, they provide memorable turning points, comfort in hard times, and creative breakthroughs. On the other, they may intensify distorted thinking when interpreted through a lens of paranoia or despair. This complexity explains why synchronicity continues to captivate both psychologists and the public. It illustrates how the same underlying mechanisms, apophenia, pareidolia, clustering illusions, and confirmation bias, can produce experiences that range from inspiring to destabilizing. Even with this understanding, knowing about these biases does not erase their pull. You might learn that apophenia predisposes you to see faces in tree bark or detect patterns in coincidental numbers, and yet you still feel a rush of recognition when life presents such an alignment. You might read about confirmation bias, and yet the next moment your lucky number appears, you feel its significance immediately. Rational explanation and emotional conviction coexist without canceling each other out. For many, the story that a coincidence feels personally fated is harder to shake than the statistics that explain it away. What's crucial here is that calling these experiences illusions does not strip them of psychological power. If a synchronicity gives hope to someone in grief, supports a difficult decision, or provides encouragement at a turning point, then it has real effects, regardless of whether the link was objectively meaningful or a cognitive byproduct. The outcome, comfort, courage, or clarity, matters to the person more than the mechanics behind it. This is why the debate around synchronicity is unlikely to close anytime soon. We know much about how the brain constructs meaning from randomness, and yet the feelings these experiences evoke carry weight in people's lives. That tension sustains conversation between psychology, philosophy, and even fields far outside of mind sciences. For some, these cognitive explanations settle the matter. For others, they only highlight the profound capacity of human consciousness to shape reality as we experience it. Which raises a deeper question. If the brain's biases can generate powerful experiences of pattern and meaning, what does it suggest about the role of consciousness itself in shaping reality? This takes us from the realm of psychology into another domain where the rules of order and observation become even stranger, and the question is no longer just about tricks of the mind, but about the very structure of nature itself. Quantum physics and consciousness. Quantum physics has long raised questions that sound uncomfortably close to philosophy, and one of the most pressing is whether consciousness plays any role in shaping reality. For years, most scientists brushed this aside as speculation, but the topic continues to resurface, partly because experiments at the quantum level defy common sense. What makes this relevant to synchronicity is the possibility, however remote, that mind and matter might not be entirely separate. The puzzle is whether an act of observation simply registers reality or, in some interpretations, helps decide what comes into being. This is usually framed in terms of the so-called observer effect. In quantum mechanics, particles remain suspended in overlapping states until measured, when they are forced into definite outcomes. The question is whether measurement requires a conscious observer, or if the effect can be explained by something else entirely, such as physical interaction with a detector or environmental noise, a process called decoherence. Some researchers explore the idea that attention itself might collapse possibilities into facts, but the majority of physicists remain skeptical, emphasizing that the evidence can be interpreted without placing consciousness at the center. The debate remains unsettled, and most experts caution that experiments so far reveal anomalies in measurement, not proof of mind-to-matter causation. Newer studies revisit these questions with refined experiments, including updated versions of the double-slit test. Some teams propose ways to isolate whether awareness directly influences quantum outcomes. Advocates argue this would position consciousness as a fundamental element of physical law, not a late byproduct of evolution. Critics reply that the subtle effects detected are far more likely explained by interference, noise, and the fragile nature of quantum states. In other words, when particles act unpredictably, the system itself is sensitive, not necessarily responsive to thought. While experiments continue, caution is the rule. There is interest in whether consciousness and quantum mechanics interact, but no accepted data confirms that human awareness changes physical events outside the mind. One area that often enters these conversations is entanglement. When two particles interact and become entangled, their properties remain linked even at great distance. If one is measured, the other responds instantly, a phenomenon Einstein dismissed as spooky action at a distance. Entanglement today is no longer in dispute. It has been validated repeatedly and is even used in developing secure communication methods. But it is important to underline that entanglement describes consistent correlations between particles, not symbolic meaning, and certainly not psychic connection. For people reflecting on synchronicity, entanglement is often cited as a metaphor. If nature tolerates non-local links at the smallest scales, perhaps our odd experiences of connection feel less implausible. But the physics itself does not extend to validating personal coincidence stories. The resemblance is conceptual, not evidential. That distinction is critical. Entanglement demonstrates that reality operates in ways our intuition does not expect, but it does not show that two friends thinking of each other at the same time are quantumly connected. What can be said is that both domains highlight gaps in classical reasoning. In one case, we have physical data demonstrating non-local effects. In the other, we have psychological experiences interpreted as meaningful coincidence. Drawing them together is more a matter of analogy than direct science. Meanwhile, some theorists explore wider frameworks linking consciousness and physics. Panpsychism, the view that consciousness pervades all matter, has been revisited with modern philosophical tools, while approaches like integrated information theory propose that consciousness corresponds to the amount of information integrated by a system. Certain physicists speculate these frameworks could connect with quantum principles, though again, this is controversial. Most neuroscientists and physicists resist any suggestion that laboratory anomalies justify attributing physical power to conscious thought. The dominant view is that consciousness remains poorly understood, but it does not rewrite quantum mechanics. That said, fringe avenues do gain attention. An example includes research probing whether anesthetics like xenon affect microtubules in neurons in ways tied to quantum coherence. Some interpret this as evidence that consciousness draws from quantum processes inside the brain. Yet this line of work is contested, with critics noting that the data are preliminary and far from conclusive. Studies remain ongoing, but no consensus has been reached. If mentioned at all, such models must be treated as speculative, highlighting curiosity rather than confirmation. For people experiencing synchronicities, the fine distinctions between decoherence, measurement, and entanglement may matter less than the impression they give. The impression is that reality is not purely mechanical, that something about attention, awareness, or connection unsettles familiar rules. Science does not endorse the idea that thought makes coincidences happen, but science does acknowledge that at the smallest scales, reality is profoundly unfamiliar. That recognition alone encourages parallels in the wider culture, where people reflect on meaning, pattern, and alignment. Still, misunderstandings are common. The leap from saying consciousness could be involved in measuring quantum states to consciousness directly shapes everyday events is vast and unproven. Physics explains behavior at very small scales, while our lived coincidences happen in the macroscopic world. Bridging that gap is far from straightforward. Caution from experts is uniform. Speculative links may be intriguing, but they should not be overstated. Where synchronicity relies on personal interpretation, quantum mechanics relies on reproducible measurement, and the two converge only in metaphor. This tension creates a paradox. On one side, physics demonstrates realities more bizarre than intuition allows. On the other, stories of coincidence feel so pointed they are difficult to dismiss. One domain gathers data and equations, the other collects private testimonies. The connection is not in evidence, but in atmosphere. Both leave us confronting a world that resists the assumption of simplicity. To many, that atmosphere is enough to justify curiosity, even wonder. The cultural effect is undeniable. The fact that consciousness is even discussed in physics, however cautiously, opens a space for dialogue where psychology, philosophy, and science intersect. Where once scientists treated the mind as irrelevant to physical law, some now admit it may play a role worth investigating, if nothing else to better define its boundaries. And for people navigating their own synchronicities, this openness lends permission. If nature itself eludes straight lines, perhaps personal experiences of hidden connection should not be dismissed outright either. Ultimately, what these debates reveal is not confirmation that synchronicity and quantum physics share a mechanism, but recognition that both challenge the tidy certainty of classical explanation. At everyday scales, we live mostly in probability and perception, while at quantum scales particles obey rules that unsettle cause and effect. Both domains remind us that our frameworks for understanding reality are incomplete. And when reality itself operates with such unpredictability, it is no surprise that events in ordinary life can feel improbable to the point of impossible. That sense of improbability, especially when lived from the inside, is where the conversation next turns.